Okay, let's go over some basic vocabulary and rules of logic. Logic is how we evaluate whether a statement is true or false and manipulate those statements. Here's an example of a statement. Statement P. The frog is green. On its own, this statement could be either true or false. For every statement, there's an opposite or negation. We use this symbol to denote that. What would be the opposite of statement P? Would be to say that the frog is not green. That's the most basic thing we can do with a statement. The next thing we can do is to start combining statements. Let me give you two statements now. Statement C. Matt has a cat. And statement H. Matt has a hat. If I wanted to combine these statements, there's two ways I could do that. The first way is to say C and H. This symbol, you can easily remember, means and because it points upward like an A. If I say C and H, that statement is only true if both C and H are true. If Matt does in fact have a hat and a cat, then it's true that Matt has a cat and a hat. If he is missing one of those things, this statement is no longer true. What would still be true is the or statement. If I said Matt has a cat or a hat, this statement would be true whenever one or both of C and H are true. The only time the or statement will be false is if both sides are false. Now we can apply all of these things we just learned to do a simple operation. This is called De Morgan's law. And it says that whenever you have the negation outside of the parentheses, you can distribute it as long as you take the opposite operation, changing and to or to and. Once again, when you take the opposite of a combination in parentheses, you may distribute the negation as long as you take the opposite of each statement inside the parentheses. If you would like to think of your own statements P and Q and why the left and right sides would be equivalent, that might help you to understand De Morgan's law. But for now, it should be pretty easy to remember. The next thing I can do with statements is make conditional statements, where the truth of one statement affects the other. I could give a statement like this. All frogs are green. That statement could be true or false, but it's equivalent to saying this. If it is a frog, then it is green. In this case, we say one statement implies the other. If it is a frog, then it is green. Whenever you see a statement with if in it, the first part before the if is the condition, and you can write out your arrow in that order. We'll take a look at some variations of that when we get into the examples. For now, if you haven't already, I would like you to think of your own examples of statements that could be conditional. What we're going to do is we're going to see what variations we can come up with. There are 3 variations that is very important to know. For every statement, if P, then Q, every conditional statement that is, there are 3 major variations. The converse of that statement is formed by flipping the sides of the 2 statements. The converse is not necessarily true, even if the original statement is true. If I said, if it is green, then it is a frog, that's different from saying, if it is a frog, then it is green. Another variation is called the inverse. To take the inverse of a statement, you take the opposite of the term on each side. Again, you can think of how this might not necessarily be true. For example, if you had the sentence, if it is sunny, then it is not raining, that doesn't mean that if it is raining, then it is not sunny. Again, you can think of your own examples. But for now, you need to know that the converse is formed by switching the terms, and the inverse is formed by taking the opposite. It's called the contrapositive if you did both of these things. That is, if you switched the sides and took the opposite. Now, what's interesting is that if the statement is true, the contrapositive must also be true. Go ahead, think of an example of this. Let's take the statement, if you are on math team, then you are cool. The contrapositive, if you are not cool, then you must not be on math team. Has to be true, because if you were on math team, you would be cool. That's everything you need to know to get you started with logic. Please watch the videos going over the problem sets for 2010, 2009, and 2012. You can do the other years, 2011, 2013, and 2014 on your own. I recommend saving 2014 for the day of the meet.